The Alliance of Information Technology and Power Management is revolutionizing the way electric power is generated, delivered, consumed. NFIC 2015 will explore smart grid landscape with an educational and informational view. We have excellent programs today. From the leading of the program will be Smart Grid 101 by Christine Herzog, the Managing Director of Smart Grid Library. After that will be Panel 1, Smart Grid Ecosystems, the personal, focusing on the energy consumer aspect. After that will be dinner from 1 hour dinner and networking. And from 7:15 to 8 o'clock will be the keynote delivered by Diane Gurnick, former Commissioner of California Public Utilities Commission. From 8 o'clock to 9:30 will be Panel 2, Ecosystems, Smart Grid Ecosystems, the public, focusing on the energy producer aspect. From 9:30 to 10 will be adjourn and networking. Understanding smart grid, the technology trends, business opportunities, its impacts and benefits to our society is the goal of this conference. We hope that you'll find NFIC 2015 educational, enjoyable, and valuable. We would like to take this opportunity to thank Mr. Richard Huang for his platinum sponsorship to this conference. In addition, we would like to thank the organizing committee and volunteers for their untiring dedication and consistent support to make this event a success. Coming up is Smart Grid 101. Christine will be our speaker. So Christine Herzog is the Managing Director and founder of Smart Grid Library. She's presently working with ESI as a technical advisor. Her background includes product management, product marketing, and partner management with various companies. She's the author of Smart Grid Dictionary, happened to be translated into Chinese as well. And she's the co-author of Data Privacy for Smart Grid. Ladies and gentlemen, please join me in welcoming Christine Herzog.
Thanks very much. Can everyone hear me without the microphone? Seems like it's a small enough room. When I was asked to, and I'm honored to be here, thank you very much. When I was asked to present on Smart Grid 101, it's like, wow, where do you start? You know, it's a big, broad area, and there are lots of definitions out there. You can find the one in my book here, but you can find many others out there. But if we want to take it down to its simplest construct, it's really bidirectional communications and electricity. Because right now we've got a grid that operates pretty much in one direction and doesn't provide very much information. So let's talk a little bit about what's going on in terms of the smart grid markets, the evolution of the smart grid, and then we'll bring it back to the personal and the public, and we'll get a lot more talk about that from our esteemed panelists today. And feel free to raise your hand, ask questions. We'll make this interactive so that it's interesting for everyone. I'm not going to read that slide. It's got a lot of text on it. But what I wanted to just show you is that you can think of the smart grid in a lot of different ways. You can take a look at it from a monetary value. Well, does that monetary value cover everything? Is it global? Is it just part of one region of a country or a continent? Does it cover solely and strictly look at one particular application area within a smart grid? Does it look at it much more broadly? So the key point to take away here is that when you talk to someone about smart grid, or when you think about the smart grid, you need to be clear on what way you're looking at it, and everyone has a very different perspective. I come at this from a telecom perspective. So for me, what makes a smart grid smart is not the fact that it has renewables on it, which is wonderful, but the fact that it has this communication network of increasing sophistication that's able to let people manage grids in a much better fashion, in not just a reactive fashion, but a proactive fashion. So the way you want to think about this is really going to be based on where are you coming from? Are you thinking about it in terms of, I want to write software, or I want to engineer better chips that are going to increase the performance, the capacity, reduce the heat, things of that sort. So there are many different ways that you can take a look at this. But one of the things that we do need to keep in mind is that we're here in a developed economy, but there is about a third of the population that's living in energy poverty in the world. And we've got to keep in mind that smart grid is not only to make our grid more effective, but it's also to ensure that we're providing electricity services everywhere that it's needed. And it's needed in some places in particular. So the UN has a very interesting initiative that they announced a couple of years ago that is going to put 30 billion, which is just a drop in the bucket compared to what we really need to do, for providing 3 goals by 2030 here. And universal access is really key amongst them. Increasing the energy efficiency technologies out there, and doubling the share of renewables. Well, that gets to something really important too, called carbon reduction, reducing greenhouse gas emissions. But again, what we want to do is make sure that we're thinking of this from the different regions' perspectives. What a smart grid means to us in the US or in North America is going to be very different for what it means for someone in India, or someone in Africa, or someone in a country where there's some developed economy but not enough. So let's take a look at what does the smart grid mean. If we look at what we've got today, we've got something that we would call a very traditional supply chain. And if we talked about it in terms of 2 of the contemporaries who were back when the first grids were developed and the first phones and networks were being put in place, it's kind of a truism that you hear a lot, that Alexander Graham Bell wouldn't recognize today's communications networks. But Edison would definitely recognize today's power grid. That's how distinctly different the rate of change has been in those 2 sectors that started essentially around the same point in time. So we have our traditional supply chain, and that means generation, transmission, which is high voltage, to distribution, which is low voltage, to the meter. That's the traditional view. It's just a one direction of a supply chain. Highly centralized planning and control. And most of the utility investments were always made in generation and in transmission. Distribution was, you do enough to make sure that you keep the lights on, but the focus had always been on generation and transmission. Now, there are a lot of different drivers in the middle there that are pushing things to this evolution in the supply chain. And what we're starting to see is now more generation at what was traditionally thought of as a point of consumption. And sometimes that's kept local, locally generated, locally consumed, but more and more, as I'll talk about what Grid 3.0 is going to be doing, that's going to be the point where we have a bidirectional flow of electricity starting. So that becomes what we call a distributed energy supply. But you can't just have that, because as you can well imagine, one of the things about the grid is keeping it very safe, in addition to keeping it reliable and cost effective. And to keep it safe, you have to make sure that any electricity that might be generated at on a line that you think is dead is actually a dead line. And so we have to make sure that we are accounting for the fact that anything that is at that point of consumption but has the ability to perhaps let electricity flow back up the line, we need to make sure that we've accommodated that, and they're working on standards to do that so that we can realize the stream of that fully bidirectional flow of electricity, but make sure it's very safe. And then we're seeing a lot more investments by utilities in the distribution and grid edges. For example, things like electric vehicles, those require charging networks. That's, again, another communications capability that's put on top of some kind of device that is a point of sale, but also supplying electricity. So the utilities have really been challenged with a lot of different drivers in addition to those there. And I'm going to highlight just a few of them for you. And one of the things that I also need to point out to you here is that every one of these types of challenges, these were challenges that the telecom industry has also faced. So when I talk about transition from centralized generation to distributed energy resources, the telecom industry went from the Ma Bell kind of concept to something that was much more distributed. You know, for the folks of you who are young, you may not even know what dial tone is, but you know, at one point in time, dial tone only came from Ma Bell, but then we created things called private branch exchanges, or PBXs, so you could create dial tone along many, many different parts of a network. So what this means here, though, from an electricity perspective, is that, you know, as you make that transition, you have to still maintain reliable grid operations. You still have to make sure that everything is designed to be cost effective. And your processes have got to scale up to accommodate, instead of just a few very large generation sources, many smaller generation sources. And you've also got to manage and optimize all that value that you're getting from a lot of data, because everything that's being attached to the grid essentially now has sensors to it, has communications capabilities to it. And that presents some other challenges too. There's a transition from the legacy solutions to new technologies. That puts a huge amount of pressure on utilities with their existing workforces. They have to learn a lot of new technologies. When you have a lineman out there and going into the future, they can't just be conversant in electricity fundamentals and how to fix a piece of gear that would be like a transformer or something else in a substation. They also have to know things about communications capabilities too, because they may be going out there to troubleshoot, why is our connection down? We were getting a wireless signal, now we're not, or it's intermittent. So they'll have to be troubleshooting more things than they used to have to do. And they're also going to have to design new processes, and not just training the workforce, but then making sure they have new processes to support the workforce as we have all new types of assets being integrated into the grid. And let's see. They're also going to have to manage regulatory challenges to business models and to the revenues. For one thing, as we are seeing, the two bellwether states for regulatory change are California and New York State. And New York is doing some very interesting things right now in terms of trying to redefine what the utility business model is. Highly regulated, monopolistic. They're trying to figure out ways to open it up, how to allow for more innovation without taking away the social compact, which is to make sure that everyone has electricity and that it's reliable, that it's affordable, that it's safe. So there, with these new forms of generation ownership that are coming up, that's going to create a lot of challenges for accommodating in terms of business processes to make it easy, to streamline it, to make sure that everything that's done is going to still ensure the safety of workers who are out in the field. And of course, there are going to be a lot of new digital energy services with new ecosystem stakeholders. We're already seeing companies that are not traditional players in the electricity sector move in there. For example, companies like Comcast, AT&T, Verizon are offering home energy management services along with home security services. Well, that's new. That's something that they weren't doing before. So at some point in time, utilities will be confronting what does this mean for them, and consumers confronting what does this mean for them too. Will these new entrants at some point say, hey, we'll offer you electricity ourselves. You get that from us. We're seeing that start to play out in certain states like Texas and Pennsylvania, where they're doing what they call deregulation and allowing many different players to become retail electricity providers, so that you may actually at some point in time, wherever you typically find yourself living, have a choice. Instead of, right now in California, it's PG&E if you live in most parts of Northern California, or it's municipal and you're within the boundaries of that city, you're getting your electricity from them. But at some point in the future, you may have more options. Not a promise, not a guarantee, but that's where a lot of different states are going in this country. And all of those business model disruptions are again going to put more pressure on utilities to again change processes, have different workforce skills in place. But one of the things that you might have read or heard about is what they call the death spiral for utilities. And that is based on the assumption that utilities today get all of their money from selling kilowatt hours. That's their source of revenue. And they are, allowed to be monopolies based on, that assumption. But in the future, as we have more energy efficient technologies coming online, as we have more sources of generation where you require less electricity from your utility supplier, that source of revenue goes away for them, or it dramatically decreases. So what does that mean for utilities when they're being asked to invest in new equipment, invest in new resources, invest in retraining existing resources, invest in changing their business processes and their models? These are questions that are tough, and they don't have easy answers. But that's where we're all going with what we call Grid 3.0. It's a work in progress, and it's got a number of different stakeholders involved in it. As you can see there's a partial list. It's open to anyone. It's a public process. And it's an initiative to take the current grid, which is in the state of evolution, to one that's going to ultimately be fully bidirectional, fully safe, have extremely good communication capabilities so that there's a lot of 5 nines reliability in terms of no dropped calls, so to speak, no drop packets, no drop messages, especially when it comes to the critical teleprotection networks. And also, that it covers all of these different needs that are listed here. Because as was pointed out in a conference I was at a couple weeks ago from a member of the Department of Energy, we've learned now that we really can't live without power. Our economy runs on electricity. We need energy in whatever form we can get it. But more to the point, and again speaking as a telecom person, and we've also learned that the grid, power can't live without information. So we need to have data, we need to have that communication stream in order for that grid to be managed effectively. So we're all stakeholders in the smart grid. And I love this cartoon because I don't know if you can read what, you have the calculations on either side, and then in the middle and then a miracle occurs. Well, that's not going to work for us in terms of evolving to Grid 3.0 to a smart grid. So what we'll be doing is talking a little bit about some of these topics today. We've got a great first panel coming up. So I guess if there's time for 1 or 2 questions, if anyone has a question, I'll take it. Yes?
I actually have a question. This goes to the slide you had that showed the business models and what folks are, what utilities are going to be facing, as well as the other slide subsequent to that talked about Grid 3.0. I'm curious, so the first question is, when you say regulatory changes, there's so many different layers of regulatory changes from a local, a state, and a federal. So that's my comment first, and then I guess secondly, is there something where you see on the horizon that's going to be more difficult for folks to figure out how to incorporate that, which gets to my second question on Grid 3.0. I noticed that the people who are participating are all sort of in the electrical energy side, and I remember the clean power thing that the president came out with, this clean power plan that talks about sort of a national related effort to look at energy as a whole. So I'm curious at some point, and maybe it'll come up later today in the conference, how that aspect is going to be incorporated into either the public or the personal side of things.
Sure. Well, just a very, very brief answer on the regulatory structures. We willingly say that the electricity sector in the U.S. is a balkanization of regulatory entities, because we have federal that really focuses on the long lines, the transmission, the high voltage. And then each state has its own regulatory commission, and that controls the monopolies in that state. And the utility commissions are typically given their marching orders by their elected state legislators and governors' initiatives. So that we talk about the 50 states being a laboratory for democracy, and I think we have 50 states that are laboratories for business models for electricity too. So there are some directives though, and other things that play in are renewable portfolio standards. California has done some marvelous things. In Governor Brown's most recent inaugural address, he essentially outlined what I would call personally the energy policy for the U.S. And one of those statements in there was to increase our share of renewables past that 33% by 2020 to 50% by, was it 2030, or 60%, I forget now. And the other one that stands out to me is that he also wants to retrofit all the existing building stock in California to be much more energy efficient. That's huge. And California is the 9th, maybe now 8th largest economy in the world. Whatever we do in this state becomes de facto the expectation for the other states. The manufacturers are not going to just make an energy efficient building here. They'll do it everywhere. So I think I've come through all my time, and I probably did not spend nearly enough time addressing the regulatory frameworks that we've got in place. But is the next thing to do to ask the speakers to come on up? Or are you going to bring them on up here? Oh, usually you wait till the end to do that. But okay. There's a bottle in here. Let's open it.